Hello guys, let's start Jeemains 2025 questions of chapter Haloalkane and Haloarenes. So in first question we have to predict the major product of the following reactions. So in first reaction we are proceeding the halogenation in the presence of sunlight. So because we are using sunlight, so it means its mechanism will be free radical. Its mechanism will be free radical. So we have to do halogenation, that is free radical substitution. So 3-degree free radical is more stable. That's why hydrogen will be removed from here and one Br will be added here. So after first reaction, we will get a product like that CH3 and then there is Br. Now we are performing the reaction with alcoholic KOH. So it means it will do the elimination reaction. So Br will be here and H will be removed from here so that we will get the stable alkene. So after the performing the reaction with the alcoholic QH, we will get our product, that is CH3, and there will be double bond. Now we are reacting it with HBr in the presence of peroxide. So again it will do the addition of Br with anti-Markovnikov rule. So addition of Br will be from anti-Markovnikov rule. So Br will be added here and H will be here. So our final product will be like that. CH3 and there will be Br. So that will be our final product. So your answer will be that is second. Next one is given below the two statements. Statement 1 is alcohol are formed when alkyl chloride are treated with aqueous KOH by elimination reaction. Yes, that's right. When alkyl halide react with aqueous QH. No, we are using aqueous QH. So aqueous QH will behave like as a nucleophile, because aqueous means OH minus ion are surrounding by water molecule, so it's not bulky. Base should be bulky. So aqueous QH means aqueous OH minus will behave like as a nucleophile. That's why we will get OH. So yes, that will be a substitution reaction. And statement 1 is correct. Statement 2, in alcoholic QH, alkyl chloride form alkene by abstracting the H from beta carbon. In alcoholic potassium hydroxide, alkyl chloride form alkene by abstracting the hydrogen from beta carbon. Yes, that is also right. In alcoholic QH, when we are using alcoholic QH, then alkyl halide gets converted into alkene. Why? Because when OH minus ion are surrounding by alcohol, so alcohol is a bulky group, so it will behave like as a base, and after reacting with alkyl halide with base, we will get alkene by removing the hydrogen from beta carbon. So both statements, statement 1 as well as statement 2, both are correct. Next one is the reaction which cannot be applied to prepare an alkene by elimination. So NaOC2H5 means it will give a base C2H5O negative, and this will behave as a base and we will get alkene. In second reaction we are using aqueous QH. So in this reaction we will get alcohol, so we will not get the alkene in B. And in third we are using 3-degree alkyl halide, and 3-degree substrate are more reactive toward elimination reaction. That's why C will also give you alkene. Next one is D. Yes, when we oxidize the phenol, we will get benzoquinone. We will not get the alkene. Our product will be benzoquinone. So D is also our answer. And when we treat it with CS3, CS3, COH, and that is 3-degree alcohol, so after dehydration, it will also give the alkene. So we have two options. Actually, we have two options, B and D, by which we cannot prepare the alkene. So our answer will be B and D only. So fourth will be our answer. Next, the question is match the column. The first reaction is fatigue reaction. So A is joined by 3. And in second reaction, that is Gatterman reaction. When we are using copper powder with HCl, then benzene diazonium chloride gets converted into chlorobenzene. So that is the example of Gatterman reaction. So B will be fourth and A will be third. Next one is C2H5Br NaI triacetone. So that is a reaction, that is halide exchange, Finkelstein reaction. So C have second option, and that is the example of Lucas test. So Lucas test, turbidity will produce, and that is, so your answer is Lucas test. So D will give your first. So according to that, A third, D first, A third, and then B is fourth. A third, B fourth, C second, or D first. So our answer will be 2. Next question is that again match the column question. So chlorobenzene, when we want to convert into phenol, due to partial double bond character, it's not a feasible reaction. We have to take a very drastic condition. That's why we have to take NaOH in the presence of 623 Kelvin temperature as well as 300 atmosphere pressure. We have to use the drastic condition. So A will match with fourth. But when we use a electron withdrawing group at ortho and para position, then it facilitates the nucleophilic substitution reaction in aryl halide. So NO2 is a electron withdrawing group when we are using one NO2, and here we are using two NO2. So if we increase the number of NO2 or electron withdrawing group at ortho and para position of phenol, then it facilitates the nucleophilic substitution reaction. So when we are using two NO2 and when we are using one NO2, so two NO2, the reaction will occurs at lower temperature, means C will match with second and B will match with, that is third. And when we use 3NO2 group at ortho and para position, then that reaction will be very easily, we can proceed very easily, because nucleophilic substitution reaction will occurs at very high speed, because we are using 3 electron withdrawing group. So this reaction means fourth reaction can be carried out at room temperature, or we can say by using just warm water. So D will be first. So your answer will be D will be first and A will be fourth. D first, A fourth. D first, A fourth, and B third, and C second. So answer will be third. Next question is that, so these are the actually questions of haloalkane and haloarenes of Jeemains 2025. Thank you.